So welcome to the Spark MLlib lab. In the first lab, we are going to take a deeper look into get hands-on with MLlib for supervised learning. So supervised learning consists of two kinds of algorithm, regression and classification. So we are going to use, as mentioned earlier, we are going to build a regression model, get comfortable with what are all the processing and how do we do it on Spark. So as always, all your hands-on will be done on Databricks, right? And I have given you the data set which you can load into your data, into your Databricks and then read it as a data frame. So time permitting, I will also show you how you can save your notebook from Databricks and then use your IPython notebook and run Colab, run the same notebook in Colab by installing your PySpark. Alright, so let's get started.
Welcome to the Spark MLlib Supervised Learning Lab. As I had discussed, we are going to first go through the machine learning process. Firstly, supervised learning, regression problem. Regression is where dependent variable, y, the variable that you're predicting is a continuous variable, right? It has multiple values. So for this problem, we are going to look at a data set called housing.csv from Kaggle. So this data set contains the median house prices for the California districts derived from their census, 1990 census, right? So I've uploaded the CSV into Databricks. So I'm just going to go ahead and start the lab. So since we are till now, most of the functions that we have been using in Spark has been part of the Spark core, right? We did do a bit of user-defined functions, etc., where we had to import. So in this, since we are going to use the MLlib library exclusively, so I've done a bunch of imports, right? So all of these imports come from PySpark ML. So if you look at it, so PySpark ML feature, so there's a lot of function related to the feature engineering part, right? So one is imputation, then string indexer, vector assembler, standard scalar, one-hot encoding. All of that you must have seen the equivalent in your scikit-learn as well. Then we have the regression. In this example, we are going to look at linear regression. I'm first going to talk about regression, but here we are doing all the imports needed for this lab, right? For then classification as well. Then we are doing the regression evaluator. So later we are also going to start looking at if there are missing value, right? Because imputation is where if you have missing value, you're going to make it a complete data set. So that is, you must have done it in your data analysis, right? When you do your exploratory data analysis. So first, we are loading the housing data set. So the housing data set and we are printing the schema of it. So it has a lot of information. So let's look at the columns that it's having, right? It has longitude, latitude, the housing median age, total rooms, total number of bedrooms, population, house holes, then medium income, medium house value. This is what we are going to predict at ocean proximity. So if you look at the data type, all of them are numerical data. So there is only one categorical data. So we are going to take a look at the data set, right? So as you can see, all of them are numerical data, only ocean proximity. So there is nearby, etc. So we'll see some examples of that. And of course, we are just checking the type of the variable. So it is a Spark distributed data frame. It's a Spark data frame, right? So another thing in this data, as you can see, there is no index column. Okay, so there is no running value. So one uh, thing, especially when you're doing big data, it might be a good idea to have a index value which will have a running number, right? So that you know that a particular row corresponds to in the data set. So that's what we are creating here. We are creating a monotonically. So from your SQL function, we are importing monotonically increasing ID, right? So we are adding this column. So in your data frame, we are adding ID, and so that will get generated from this function, monotonically increasing ID. And then we are making this ID column the first column, right? So we are just shifting the, so if you look at it, what happens? So you have a new ID column which has increasing values 0, 1, 2, 3. So we are looking at only top three. Then, of course, we want to know how many rows are there, right, in your data set. So there are about 20,640 rows. So before we go into the machine learning aspect itself, we are just doing some exploratory analysis. We have in this lab, I haven't gone through the exploratory data analysis in detail. I have left that to you to explore, right? So first thing is you want to know, hey, what is the average um, total number of rooms in this data set, right, in the whole data frame, right? So that is what this is. And then we are also doing a group by and looking at the average value of every column group by this ocean proximity, right? So here we are looking at 3 to the end. So other than the latitude and longitude, go ahead and look at. Okay, so the ocean proximity is island, near ocean, near bay, um, ocean, inland. These are the categories. So the corresponding average value of household, average value of population, average value of total bedrooms, all of it is shown here. Okay, so you can go ahead and do some more exploratory analysis. So in fact, you can also do some visualizations in your data as well using your Spark SQL. So now let's get started with the machine learning process. So the following steps will be done, right? So first we'll do the train test split, right? And then we will start imputing your, we'll look at the number of null values. Imputation is a way of filling up null value. Of course, imputation has a lot of, it's a topic by itself because data science with missing data, it's a problem of its own. So most often we tend to see that, hey, you can impute by the mean value, but that is not the right way because what you're doing is you're generating data essentially, right? So you have to be actually very careful when you do imputation. So in this case, because that is not the aim of this lab, we have gone ahead to use a standard imputer in order to impute your data. So of course you can impute using your regression model itself, all of it, right? And then check and we are going to impute the null values, then normalize your numerical data. Then there's one categorical data to deal with, so we'll deal with that. And then we'll create a vector because in Spark we have to create that vector column, right, which has all of the vectors. So we look at that and then we are going to generate a linear regression model on using the training data set, then use the model to create predictions on the test data set and evaluate your model. So here we are using your train test split, right, random split 70-30. So the 42 is essentially a random seed so that your results are reproducible. So this has created two uh, data frames, train and test. Okay, so now we are collating all of the numerical data. So all of the columns are numerical except your ocean proximity. So we are dropping ocean proximity. We are also dropping ID because it's just a monotonically increasing. There is no relevance to the dependent variable whatsoever. And then the median house value, right? So that is what we want to predict. So that needs to be dropped, right? So we are creating a list of all the numerical features. And then we are going ahead and seeing the number of null values in each of these columns, right? So none of the columns have null values except total bedrooms, right? That seems to have 136 null values. So imputer is essentially, so we are creating an object of, so imputer is from, this is the function itself. So we are creating the column from your numerical list. An output column, it's a transformation. That's what it's going to do, right? So it's a transformation. So we are fitting using the train. So if you look at the imputer itself, so the strategy by default it uses is mean, right? So that means if there is a missing value, it is replacing by the mean, right? So if there are, there are multiple strategies to filling these null values. So in this case, we are using the standard mean. So fitting the training data and use that to fill your train and test, right? That is very important because this is something which is very important in the machine learning process, because your test data is something that the model doesn't see. The model just says the training data, right? So we are going to use the training data statistics to fill in your test data as well, because that is what is going to happen, because there is no test data mean really, because test data is what is coming in, what the model has not seen. So that's why you fit using your training data. So what this step does is it calculates mean of all numerical column. Okay, so then we are just checking again if there is null value after imputation, right? So your uh, train data frame has what is been already imputed, so there is zero null values. So now we are ready to get started with your vector assembler. So vector assembler, typically if you don't give it the input and output column, right? What happens is it will create a new column called features, right? Where it will create a vector of all the numerical ones. Here we are giving what are all the inputs, all your numerical data, and we are creating an output column called the numerical feature vector. Okay, so and then again this is a transformer, so you're transforming your train and test independently. And then we are looking at the numerical feature vector, which is the new vector that got created. So you can see this is the new vector. So here we are only looking at that column. Okay. So if you want, you can do a show of the entire train data set. So you'll see that to the last column that got created. So then we are doing, so since each of it is see, each of your feature is in different scale, right? So one is the median income, one is the number of bedrooms. So each of these ranges have multiple scale, different scales. So we need to normalize our data. So we are going to use the standard scalar, right? So there again, so you're using your numerical feature, which is the new column that you've created, and creating another column called the scaled numerical feature vector, right? And we are saying with standard deviation true and with mean true. So what that means is, what is the formula that gets done, right? So the scaled value is equal to the original value minus mean divided by the standard deviation. Right? So this is what standard. So this gets done for each of the column. Each of the columns mean is taken. So the fit again, it will just calculate the mean, and then we transform your train and test. All right. So this is also very similar to what we have seen earlier. Like your imputer, you always fit only on your training data and transform your train and test. And then this is your scaled numerical data. Right? So you can see that the values, so these were the values. So those are all now scaled down. Okay, so now we will deal with the categorical variable. So what is the categorical variable that is there? Ocean proximity. So the first thing we do is we will convert it into an index. So we are going to use a string indexer for converting it into an index. right? So index is just going to give 0, 1, 2, 3, right? So this is again a transformer. And then on the ocean category index, right? We are going to do a ocean category index is the input column. We are going to do a one-hot encoding. Okay. So the output columns are ocean category one hot. So let's do this. Okay. So here, if you look at it, so you can see that your ocean category index got created, which is basically giving an index, right? If you remember, all the first rows were near bay, so 3 is the index given to near bay, and that has gotten converted into a one hot encoding. So this is a little different because it's not saying 001, right? So it's giving you a certain way because this one hot encoding is stored in a sparse metric variation. Okay, because if you look at one hot encoding, there are more zeros and there is only very few places which has one, right? So what a sparse vector does is it just stores the locations where there is one, right? So that is why this shows a little funny. It doesn't show 001, right? It shows 4 comma 3 comma 1, right? So it's essentially a one hot encoded vector. And then now we are uh, combining the numerical and a one hot encoded vector. Okay, so this is your scale numerical feature vector, then your ocean category one hot, and this is your output vector. So now it is all ready. Okay, so let's take a look. Okay, so the whole final feature vector is there. So now we are ready for modeling. In this case, we are creating a linear regression model. So the final, so this is your feature column and this is your label column. So if you don't specify this column explicitly, so we'll see that in another lab. So you will see that it is looking for a column called features. Spark is looking for a column called label, right? Else it will not work. Okay. So here we are explicitly calling out which are the columns that has the feature and then fitting. So this is going to take a while, right? So the LR object is your model. So we are just trying to see what is type of LR. So it's a linear regression model, right? So once you have that model, so now it is a transformer. So now you can pass on data to it and it will give you prediction. So every prediction, right? So unlike your sklearn library, you will not get only the prediction. So what happens is your data frame will just get transformed with a new column called predictions on it. Okay. So that is what we are doing. We are passing in the training data. So we are getting predictions on the training data set, predictions on the test data set so that we can evaluate, right? So it will create a column called prediction, this transform function, right? After you fit the model, when you do transform, it will create that prediction, which we are renaming it as predicted median house value. And we are putting it into a prediction train data frame. Okay. So prediction train data frame has every column and it also has the predicted mean this thing of only the training rows. Okay, so the same thing for your test. So now we are doing oh yeah, so I think this is not needed. So now we want to evaluate it. So we have gotten the test data, pred underscore test underscore df. So we are creating the LR. So we are looking at the R square on the test data. So that is 0.649. So almost 0.65. right? So your R square value ranges from 0 to 1. So the closer it is to 1, the better the prediction, right? So of course you can do any of the feature engineering, etc. on it and try if you can improve your data, your R score. Then we are also going to do your RMSE, so your regression evaluator. So we are sending in your predicted median value score of your predicted test data set, right? So, and the label column is your median household so that you can calculate the root mean square error. So, the root mean square error, so you have error of plus or minus $68,450 in this case, the median household. That seems to be a little large, right? So, of course, maybe there is a different model. So you can try out other models like your random forest regressor or your k-nearest neighbor, etc., and see if you are able to get your R square and your RMSE. R square higher, RMSE lower. That's what we evaluate good models with, right? So try it out, right? So walk through each of the procedure, right? So in the next video, I will talk about the classification. So this is a continuation of the supervised machine learning lab. So we took a look at regression. So in this activity, this part of the notebook, I have decided to get your hands warmed up with Spark MLlib. So it's your turn now to create a classification model. Okay. So you're all aware of the iris data set, right? So the iris data set contains four features: the length and width of the sepal and petals of 50 samples of each of a kind of orchid iris flower: iris setosa, iris virginica, and iris versicolor. Okay, so go ahead and create a random forest classifier with the number of trees equal to 50 and max depth 3. So here I'm just going to show you the data set so you can get comfortable with it. Right, so you have the sepal length, petal length. So this is your Spark data frame as well. So as you write your code, go ahead and create your new cells. Okay, so here I'm going to just show you the data set. So let's say the top 3, right? So this is your data set. So you'll have to use indexer, string indexer to convert your species, right? And use so that will be your target variable, and all of these would be your independent variable, your predictors. So go ahead, use your vector assembler. Of course, you can use your logistic regression also. Try it out. So since we use a linear model, I thought this in this case you can try and use your random forest classifier. All right. So have fun with building your classification model. All right. In this lab, I'm just going to show you how you can download your Databricks notebook into an IPython notebook and actually run the same code using Colab. All right. So you're done with your regression and classification, right? So you can go ahead and go to export and download as an IPython notebook. So this will get downloaded as a .ipynb, so a Python notebook file, right? So what I have done is I've gone ahead and added this Python notebook that I have downloaded into my uh, Google Drive, okay, so that it is there. So I've opened it. I'm going to show you how you can run this. So I will also share this file with you as part of the lab, right? So you can look at it. So what you first need to do is you need to do a pip install of PySpark, because PySpark is not already available in your Colab environment, right? Otherwise, after you install it, then you are good to go. You can import all of it. It's all fine. All you also have to create a Spark session. Okay, so from your Spark SQL, import Spark session, right? So you're saying, hey, you're calling it from Colab, right? Then the next thing is you have to read your data, right? So how do you read your data? So in your Databricks, we added the CSV into the Databricks file system, DBFS, right? So here, go ahead and upload your housing.csv, right, using the upload button, or you can just drag and drop from your folder into this Colab notebook. So as you all must have seen, Colab is a temporary virtual machine again. So every time you have to run this machine, run this notebook, you will have to reload the file. Now you no longer are loading it from your file store, right? So you just have to change it to saying that, hey, load your housing.csv, which is in the same local folder, right? And we are setting your header true and your info schema as true, and then you should be able to get your schema done, right? So then you can go ahead and look at your data and do the same thing as what you did in Databricks. So I just wanted to give you this perspective as well, so that you are aware that you can actually run your um, notebooks on the Google Colab environment, because that is free as well. Thank you.
So in this module, we have taken a look at Spark MLlib supervised learning lab. We looked at the regression model in detail for the California housing dataset, and then I have given you some work to get you hands-on on Spark MLlib library as well by trying out the iris dataset for your classification problem. Alright, so I'll see you in the next video. Thank you.